This lesson we're going to be looking at another shortcut for finding the derivative, and we call it the product rule. Now we call it product rule because if we can write our function as the product of two other functions, so we're just going to introduce u multiplied by v, so two new functions u and v. If we could write it as one thing times another, then we can find the derivative by this little rule here. We go the original u times the derivative of v plus the original v times the derivative of u. Okay, in the other notation, you could write it as dy dx equals u times dv dx plus v du dx. Okay, let's have a look at an example. So, let's say we're given the original function x plus 1 all multiplied by x squared minus 3, and let's just raise it to the power of 3 as well. So let's say f of x equals this. To find the derivative, we'd have to let the first bracket equal u. So u can equal x plus 1, so therefore the derivative of u would be just 1. And v can equal this second bracket, and so the derivative of v would be 2x. Oh, no, I've stuffed that up, haven't I? That should be all of that cubed. So then I'd have 3 times x cubed minus 3 squared multiplied by what's inside, the derivative of what's inside the bracket, which would be 2x. So that would be 6x times x squared minus 3 all squared. So final step to put that into the derivative for f of x. So remember from our formula, we're going u times v dash plus v times u dash. So I might write it down here as well just so you can remember, u v dash plus v u dash. I've just shorthanded there and left off all my x's, but just make sure you're finding the derivative with respect to the same variable. So u in this case was x plus 1, so x plus 1 times v dash, which is this big thing here with the 6x, so that's times 6x x squared minus 3 all squared. And I should be plussing, shouldn't I? Not minusing. Why am I minusing? So that should be a plus. And then v in this case is x squared minus 3 all cubed times u dash, which is 1. So times by 1. So tidying that up, I would get 6x times x plus 1 times x squared minus 3 all cubed plus x squared minus 3 all cubed. I could even take a common factor out there if I wanted to. I would have x squared minus 3 all out the front, and that would go into, this would be 6x squared plus 6x, goes into that many times, and I'd have plus x squared minus 3, which, tidying that up again, I would have x squared minus 3 cubed. Then I could expand it or simplify here, collect our like terms. I'd have 7x squared plus 6x minus 3. So tidying up the algebra, it's a little bit tiresome, but this little rule here will save you a lot of time. Imagine trying to do that by first principles. So have a go at the product rule. Like I said, the more complex the original functions are, so the more complex u and v are, the more complex the derivative is going to look at, the more tidying up the algebra you're going to have to do. But if you follow that rule and then just simplify, you should be able to find the derivative for f of x without too many hassles.